Hi, my name is Ellie Hart, and today I will be discussing the kinetics problem, solving for the reaction rate law, rate constant, and the order of the reaction from data. So here's our problem. It states the tabulated data were collected for this reaction. 2 nitrogen dioxide gas plus 1 fluorine gas forms 2 nitrogen dioxide fluorine gas. And then we have the concentrations listed of NO2 in the first column, the concentrations of F2 in the second column, and the rate in molar per second in the last column. And the question is asking us to write an expression for the rate law and calculate the value of the rate constant K. What is the overall order of this reaction? So first we're gonna define some variables or some equations. So we have that the rate is equal to the rate constant, which units vary by order. So in a 0 order reaction, we'll have it in molars per second. In a first order reaction, we have it in seconds to the -1. And in a second order reaction, we have it in molar to the -1, second to the -1. For A is the concentration of reactant 1 in molar. N is the rate order of reactant 1. B is the concentration of reactant 2 in molar. And M is the rate order of reactant 2. Next, we're going to use this to figure out what the rate order of each reactant is. So we're going to find 2 experiments where one of the concentration changes, and we're going to put the larger rate of over the smaller rate. And then we're going to use the corresponding concentration of the changing reactant, which is going to be the concentration in the experiment 1 for A for the top, and over the concentration in the other experiment at the bottom. And we're going to put that to N, which is going to be the rate order for reactant 1. And finally, to find the rate order, we're going to add N and M. Okay, so now we're going to do it. So here are our experiments. We're going to first solve for NO2, for the rate order for NO2. So we have that the rate 1 over rate 2 equals K times the concentration of A sub 1 to the N over K times A sub 2 to the N. And so we're going to find the 2 equations where F2 is not changing, but NO2 is changing. So that's going to be experiments 1 and 2, and we're going to put the larger rate on the top. And when we do that, this is going to be our equation. So we moved the things from the second equation down here, and then the first experiment to the bottom. And then when we solve for that, we find that the units cancel here, units cancel here, K is going to cancel, and we end up with 1.96 equals 2 to the N, meaning N equals 1. For F2, we're going to use the same equation. I just substituted B and M since this is our second reactant. And we're going to use the second and third experiments because in this section we can see that the concentration of F2 is changing, but not the concentration of NO2. And so we're going to put that in an equation. And again, the units are going to cancel. K is going to cancel. We're going to end up with 2.02 equals 2 to the M, and N equals 1. And so our final thing is that rate equals NO2 times F2 times K. So rate equals K times NO2 times F2. And now we're going to solve for K. So to do that, we're just going to plug in the data from one experiment. I chose the fourth experiment just because we haven't touched it yet. So we're going to put that in. We get 0.411 molar per second equals K times 0.400 molar times 0.400 molar. We have 3 significant figures, and when we solve, we end up with K equals 2.57 molar to the -1 second to the -1. And that's good because we found that should match up hopefully with the order that we found. And so our final rate law is going to be rate equals 2.57 times NO2 F2. And then to solve for the total rate order, we're going to know that that's going to be N plus M. N equals 1, M equals 1, so our rate order is 2. And that matches with our derived units for K, so that's good. And to conclude our summary, so to find the rate law, we've used these two equations. Here are the corresponding variables and what they mean, and then what their units are. And then to find the rate order, we added N plus M. We found that the rate was equal to 2.57 times the concentration of NO2 times the concentration of F2. And that K is equal to 2.57 meters to the -1, second to the -1. And there is a rate order of 2. Thank you.